Hello everyone. In the previous video, we have seen the theoretical basis of product limit estimator, which is also known as Kaplan-Meier estimator. As we all know, product limit estimator or Kaplan-Meier estimator is used to estimate survival function of the population. In this video, we will see how product limit estimator actually works with the help of example. So suppose we are provided with the data. Suppose 12 components are put on a test and we are observing their failure time. So out of these 12 components, the first failure got occurred at the time point 142. Suppose data is observed in some time units. So 142 is the first time point at which one of these 12 components have got failed. So 142 is a complete failure observation. Now out of remaining 11 components, any one component have got failed at time point 149. Then out of remaining 10, the next failure have occurred at time point 320. So suppose if we consider ourselves at time point 340, then there are 9 components working in the system. Initially we were having 12 components with us, out of which 3 components have got failed at the time point 142, 149 and 320. Because of which we are now left with only 9 components. But because of some reason, out of those 9 components, one component have been removed from the system at time point 345. So at time point 346, what we are having are just 8 components. One component have been removed at the time point 345. It doesn't mean that the component has failed at the time point 345. It is removed because of some other reason. The reason must be different than the failure. So we know that the component has not failed at time point 345. Whatever component we have removed has not failed at the time point 345. In fact, we know that the component was still alive at the time point 345. So whatever its actual failure time is, that time must be greater than 345, because up to 345 we have observed that component and it was alive at that time point. So its actual failure time must be greater than 345. So in order to denote this particular fact, we put its observation on that particular component as 345 plus. So 345 plus means some observation which may be greater than 345, or at the worst it may be equal to 345. So these are nothing but right censored observations. So actual failure time, we don't know about the actual failure time, but we have a partial information regarding actual failure time, and the information is that the failure time must be greater than 345. So suppose whatever data we are having, in that data all observations may or may not be complete observations. So as we can see in this particular data, out of 12 observations, 8 observations are complete observations. That is, actual failures of those components have been observed, whereas 4 components have been removed from the system, or we can say withdrawn from the system because of some other reasons other than the failure. So how to analyze this data? If we want to find out estimator of a survival function using this data which is having some censored observations. Suppose in case there were no censored observations, if entire data was a complete data, then just like empirical distribution function, we would have obtained empirical survival function, and that will be the best estimator for population survival function. But since the data contains censored observation, therefore there is need of some other method which will estimate survival function efficiently. So suppose the data is considered here in the column T bracketed J. These are the order statistics. It is not like first component out of those 12 have failed at 142. Whatever failure times are there, we are considering order statistics data on those observations, and the order statistics data is provided like 142, 149, and so on. So the component that has failed at time point 142 may be the first component, or it may be seventh component, or it may be 12th component. Any component can fail at that specific time. So T bracketed J is order statistics data on the observations. So these are the values of T bracketed J. Now at any given time point, how many failures have been occurred, that we have to consider. Here, as we can see in the data, no 2 points are same. It means we are provided with the data which is having no time. Therefore, at any given time point, maximum of one event can happen. Suppose if we consider time point as 153, as it is observed from the data, as it can be seen from the data, there is no event which has been occurred at point 153. So number of deaths at the time point 153 must be 0. So we'll have one column which will count number of deaths. So 142 is the first observation, and that observation is a complete observation. It means that there was a component which have failed at time point 142, and therefore here we have to write 1, because this particular time point 142, at this specific time point we are having one failure, and therefore D1 will be 1. Again at time point 149 we are having another failure, and therefore D2 will be 1. Similarly 320, at time point 320 we are having another failure, therefore it will be 1. Now 345 plus, if we are considering 345 point, at that point there is no failure occurred. That is a sensor time. We have removed one component at that specific time point. Failure has not occurred at that point. Just removal has occurred at that specific point. Therefore, failure or number of deaths at time point 345 must be 0. So here we will write 0. So the observations which are complete observation will have corresponding DJ value as 1, and the observations which are censored corresponding to those observations, D value will be 0, because those are the removal, those are not deaths. These are just removals from the system, not the removal from the universe. Wherever there is removal from the universe, in short, wherever there is a death, we are having DJ as 1. Now, at a specific time point, one death has been occurred. Just this information is not crucial or useful. How many components were there at that specific time point, out of which one failure has occurred? That thing also has to be considered. And therefore, we will have another column as Nj, and this is nothing but number of components in the risk set. So, at time point 142, Nj, that is risk set cardinality, will be number of components those were working just prior to the time 142. There were 12 components at the start of the system. First failure has occurred at time point 142. Therefore, just prior to 142, before that failure, just say at time point 141.9, we were having all 12 components in the system, because there is no failure from time point 0 to 141.9. Therefore, we will have entire 12 components with us just before the time point 142. Then at exact time point 142, one component will get failed, and therefore if someone asks us how many components are there in the system at the time point say 143, then we will say there are 11 components. We started with 12 components, but one component got failed at time point 142. So now we are having 11 components, and we will continue to have those 11 components up to the time 149, just prior to the time 149. As soon as we reach the time point 149, there is one failure, and therefore we will lose one more component, and then we will have number of components 10 with us, and therefore At time point 149 or 150 or 179 or 220, we will have 10 components with us. Therefore, at next time point 320, if someone asks how many number of components are there just prior to the time 320, then there will be 10 components with us. And therefore, this nj value for j is equal to 3 will be 10. Now, just prior to the time point 345, we will have 9 components with us because we were having 12 components at the start, out of which 3 components we have left at time point 142, 149 and 320. Therefore, just prior to the time point 340 plus 345 plus, we will have 9 components with us, right? Then just suppose at time point 346, how many number of components we will have? So we will have 9 components with us, right? Because sorry, 8 components with us because out of 12, 3 components have failed at time point 142, 149, 320, and 1 component have been removed at time point 345 plus. So 3 failures and 1 removal. So 4 components have left the system, and therefore now we will have 8 components with us after time point 345. So just prior to the time 5.560, we will have 8 components with us. So here we will have 8 components with us. Right. So at time point 560, we will have 8 components with us. Sorry. We will have 8 components with us. Similarly, we can complete this particular column. Suppose here, if we consider an example, at time point this particular 8 time point, we were having just prior to the 8 time point, we were having 5 components with us. One failure got occurred at time point 1720, so one removed, one component failed. Then at time point 2480 plus and another time point 4210 plus, two components are removed. So one failed and two components removed. So total 3 components have left our system, one because of failure and two because of censoring. And therefore 5 minus 3, 2 components will be there just prior to the time point 5280. And therefore nj is 2 whenever j is equal to, for the value j is equal to 11. Now this nj is nothing but the magnitude of risk set or cardinality of the risk set. Now we will calculate probability of surviving through this specific time point. So we will have another column as probability. Now what are the chances that you will go beyond 142? Suppose the situation is like this, 12 components were there, we tried to go beyond 0.142, and while trying in going beyond 142, 11 components succeeded in going beyond the time point 142, whereas one component got failed at time point 142. Therefore, out of 12, 11 components were able to go beyond 142 and one component was unable to go beyond 142. So failure chances at 142 will be 1 divided by 12, and probability of success, probability of going beyond 142 will be 1 minus 1 upon 12. So it will be simply 1 minus dj upon nj. So it will be 1 minus, it will be 1 minus dj upon nj. Now dj upon nj, that is number of days divided by number of failures. If out of 12, suppose 6 components would have failed at time point 142, then the failure chances at 142 would have been 6 divided by 12. Or suppose 10 components have been failed at 142, then the failure chances at 142 will be 10 divided by 12. Now we want survival chances beyond 142, and therefore we have considered 1 minus dj upon nj, and that probability is coming out to be 0.9166. So if you were alive just before the time point 142, then there are 0.91 chances that you will be alive after just after the point 142. So just prior to 142, if you were alive, then with chances 0.91, you will pass to the point 142. Now again for the time point 149, there were 11 components out of which one death has occurred. Therefore, failure chances at point 149 will be 1 divided by 11, that is D2 divided by N2. And the surviving chances at time point 149 will be 1 minus D2 upon N2. Therefore, this will be 1 minus D2 divided by N2. Now again, same thing can be done at time point 3, 4, 5, 6, 7, 8, 12. Now here, since at the time point 4, we don't know that the actually it is given that 345 it is the censoring, it is the censored observation, that is death has not occurred at time point 345, it is removal of a component, and since it is a removal we will not be able to calculate survival chances at that specific point, and therefore we will not be calculating this particular value at time point 4. So here we will have the dash. So these survival probabilities will not be calculated at the time point at which no death has occurred. So survival probabilities will only be calculated at the time points which are having a death at that specific time point. So sensor time points, those at those time points we will not calculate probability of survival. Now these are just suppose if we consider 0.875, what that probability means, it is not the probability that you will survive beyond 0.560. It is the probability that you will survive beyond time point 560 if you were alive just prior to the point 560. So this is a conditional probability. I will repeat again, it is not the probability of surviving beyond time point 560. It is not the probability of surviving, it is not the probability that your survival time will be greater than 560. It is the probability that your survival time will be greater than 560 given you were alive at the time point 560 minus, that is just prior to the 560. And therefore this is a conditional probability. If I want to calculate survival probability at time point 560, then it will be the probability that I will go beyond 560 provided I was alive just prior to the 560. This probability into probability of being alive just prior to the time point 560. So we'll have survival probabilities for time point 1. If you were alive at time point 142 minus, then there is probability 0.9166 with which you will go beyond time point 142. Now this is first time point, so whatever unconditional probability is there for this particular specific time point, same unconditional probability will be treated as conditional probability, because whatever number of observations were there at time point 0, all those observations, all those components were available at 142 minus, and therefore it will be simply this probability 0.9166. Now here we want to calculate survival probability at time point 149. So we want to calculate probability that capital T will be greater than 149, greater than 149. Actual survival time will be greater than 149. So in order to have actual survival time greater than 149, basically you should be alive just prior to the time 149 minus, And then if you were alive at the time point 149 minus, just prior to the 149, then what is the chance that you will go beyond 149? So these are the chances that if you once if you cross 142, then according to the data you will go up to 149 because there is no failure in between. Therefore, this is the probability of reaching just prior to 149. So you have to reach just prior to the 149, and once you have reached there, then you have to go beyond 149. So basically, this has to happen first. Once this happens with priority 0.91, then you are just at the time point prior to 149. Once you are there, then you have to cross 149, and that you can cross with this specific priority. Therefore, this priority, unconditional priority that you will go beyond 149 will be product of two probabilities. The first, probability of being alive at time point just prior to the 149, and then it will get multiplied by the probability that if you were alive at time point just prior to 149, then the probability with which you will go beyond 149, that probability will get multiplied here. So similarly, at time point 320, we can have calculation. I will drag this and then I will delete the intermediate value. This value should be deleted, right? Because we are not calculating survival probability at time point 345 plus. Now here, in order to calculate survival probability at point 560, basically you have to be alive just prior to the 5.560 minus, and that can be done with probability 0.75. And therefore here we'll have G9. So 0.75 are the chances that you will go beyond 320. So if you are going beyond 320, then there is no failure in between. Whenever we are calculating survival function, we are considering only the failures, and therefore 345 plus, it is not a death event. Therefore, that will not hamper this probability. If you have successfully crossed 320, then you will be there just prior to the up to the point 560, just prior to the point 560, because there is no death in between. So whoever crosses 320 will reach the time point just prior to the 560, and therefore this probability is getting multiplied with this probability. Here again the same thing, 0.65 into 0.85, so this will be the probability. Here we will not be calculating probability as this is a sensor time point. Again here we'll have to change this particular formula here, because the previous observation is censored, so we have to consider observation previous to that also. Therefore here we will have to write G12. Again we will not be calculating probabilities here. I will delete this value, I will delete this value. Now at this specific time point, survival time at time point 5280, it will be product of two probabilities just reaching to the time point 5280, that probability is 0.45. So I will change this particular thing. I will give cell address of 0.45, it is G14. You have to reach the point 5280, and in order to reach 5280 you should be successfully crossing the time point 1720. Once you cross that time point, then you will reach 5280, because whatever happens in between are not deaths. Therefore this probability is the probability of reaching to a time point just prior to 5280. Once you reach there, what are the chances that you will be going beyond 5280? Those chances are 0.5. So multiplication of these two things will happen here, so it will come out to be 0.225, and again here it will be 0. Now suppose if I am having 12 components and the failure times have been given like this. The last failure have occurred at time point 6890. So if someone asks what is the probability that you will go beyond time point 6892. So if all 12 components are getting failed up to the time point 6890, then there are no survival chances beyond time point 6890 because the last individual, the last component have failed at 6890. So therefore, no component is there in the system beyond that time point. So survival chances beyond that time point must be zero, and that is what is reflected here. We are getting survival chances of the last component as zero. So these are the survival probabilities and these are calculated at these complete observations. And therefore, since there are some censored observations in between and those are losing our continuity, so I will just have another table where I will have continuous data. So whatever time points we are having, or those time points will be considered here, and those time points will be considered only if death has occurred at that specific time. Then only those time points will be considered. So these are the time points at which we are having actual death observation, actual failures in this case. So these are the time points at which death have occurred. So at these time points, the number of individuals, those were at risk, that is taken here n dot risk. Those are nothing but these specific values. So I will just copy paste those values here. Now, number of events, how many events have occurred at this specific time point. Since we have considered data with no ties, we will have only one event at this specific time point. Therefore, all these values will be 1. And what are the survival probabilities at this specific time point?